Hello, today I'm going to be going over how to divide rational expressions, but first I'm going to start with this review multiplication problem and then move on to the division. So first I just have this example problem here, and if you remember, the first step in multiplying rational expressions would be to factor. Now this is already factored, so you can't factor this further. So next would be to write the domain restrictions. So the domain restrictions for this are x cannot equal 0 because 2 times 0 is 0 and the denominator cannot equal 0. And x cannot equal -3 because -3 plus 3 is 0. Okay, so the next step would be to just simplify. So cross out common factors. You can cross cancel, but you can't cross cancel in this one. If it was a different problem, like you had an x plus 1 here and an x plus 1 here, then you could cross cancel, but that's not the case here. An x up here and an x down here. So those two cancel, so I'm just going to mark those out. And then that's all you can do for crossing out, dividing common by common factors or cross-canceling or canceling. So now all that's left is to multiply. So in this problem, you would get x plus 1, the quantity x plus 1, multiplied by the quantity x minus 2 all over 2 times the quantity x plus 3. And if you remember, you will leave it in factored form, so this is simplest form. And here are your domain restrictions. So the final answer is right here. Okay, so now to move on to division. So here is my division checklist. It starts out the same as multiplying, where you will factor everything and then state the domain restrictions. So I have a division problem here that I'm just going to use real quick. How about this one? Okay, anyway. This is the problem. So first you want to factor. And I actually got this problem off of a worksheet I have. So it's an actual problem that you might see. It's a normal problem you might see. Okay. So first you're going to factor. And in the numerator right here, you can factor out the 4. So you get 4 times the quantity x minus 2. And on the bottom, it's a difference of squares, so you get x plus 2, x minus 2. Try to write quickly. It's kind of hard to write on a computer with no actual mouse. That's beside the point though. And then over here, you can't factor that. it's factored as far as it will go, so I'm just going to rewrite it here. 3x over x plus 2. So next on the checklist would be to state the domain restrictions. For now, just look at the denominators, and so you can tell that the restrictions are x cannot equal positive or negative 2. Cannot equal negative 2 over here. Cannot equal negative 2. Cannot equal positive 2. So I'm just going to write it as x cannot equal positive negative 2. Like that. And so if you look at the next step, it would be multiplied by the reciprocal. You'll recall that the reciprocal would be to flip the second fraction, and you get x plus 2 over 3x. So I'm just going to do that real quick. So multiply. That's, I know it's an x, but that's for multiplication. And x plus 2 over 3x. Okay. I do not like that multiplication symbol I used. There, that's better. Okay, so next would be to write additional domain restrictions, and I'll show you why. Okay, so now since you flipped this fraction, it has a different denominator. So now x cannot equal 0. And I'll show you why right now. Let's say that you had 1 over x. This is a different problem. Just 1 over x divided by y over x. So if this were a multiplication problem, x cannot equal 0, and that would be all for the domain restrictions. However, when you flip it by the reciprocal, multiply by the reciprocal, you get 1 over x times x over y. And actually right here, the x's would cancel, but that's not the point. The point is that y cannot equal 0 now. So looking back at this original problem, the numerator of the second fraction cannot equal 0, and the denominator of the second fraction cannot equal 0. Because let's say that actually, over here, let's say that that's a z. So in this original problem, the x cannot equal 0. You know that. If you get y over 0, then the expression is undefined and you can't have that. So z cannot equal 0. But since it's a division problem, you multiply by the reciprocal and you get z over y. So z divided by 0 is undefined, and you can't have that either. So y cannot equal 0, and z cannot equal 0. That's why you have to write additional domain restrictions, because essentially you're writing restrictions for the numerator and restrictions for the denominator. You could do that all at once. So I could just look at this original problem and say, oh, x cannot equal 0 because it's in the numerator of the second fraction. But stepwise, when you flip the fraction, you multiply by the reciprocal, then you can actually see this factor on the bottom, and you can see why you need additional domain restrictions. Now, moving on from that, next, cancel out common factors. So in this problem, you have an x minus 2 here and an x minus 2 there. Those cancel. And you can also cross cancel, and you see that you have the x plus 2 in the numerator up there, and the x plus 2 in the denominator down there. And then all you're left with is a 4 in this fraction, and this would be 1 over 3x because everything canceled on the numerator. So when you multiply, which is step 6, you get 4 over 3x. X cannot equal positive or negative 2, and it also cannot equal 0. So positive, negative 2, and x cannot equal 0. I'm going to try to put that in brackets or braces. There. So this would be your final answer. Okay, now I'm going to do one more problem, so I'll be right back. Okay, here's the next problem, and for time's sake, I have already factored it. I haven't done any of the other steps, I just did step 1, which is factor. And when it's still in this division form, I guess you could call it, you don't cancel right now. You have to multiply by the reciprocal first, and of course you have to state the restrictions as well. So I am going to add the restrictions real quick. So I just wrote those in. X cannot equal positive or negative 3. X cannot equal positive 3, which I already wrote, and x cannot equal negative 1. So the next step would be to multiply by the reciprocal. So this first fraction, or the first part of the rational expression, would stay the same. I'm just going to move it. No, I'm not. I'm going to copy that. Okay. And this second part, I'm going to rewrite by multiplying by the reciprocal. And so, let's see. Multiply by the reciprocal, you get x minus 3 times x plus 1, and over x plus 4 times x minus 1. And you get that. Let me draw in that fraction bar and multiply now. Okay, so now you have to write those additional domain restrictions, and I showed why in the last problem. So now x cannot equal negative 4, and also x cannot equal 1. So next would just be to cancel out common factors or divide by common factors. X minus 1 cancels. This is the fun part. So that cancels. The x minus 3, those cancel, and you are left, oh, that cancels as well. So basically this fraction turns into 1, just the number 1. So basically you're left with x plus 1, x plus 1 over x plus 4, and you multiply that out. And then the domain restrictions, x cannot equal positive, negative 3, that is a positive negative 3, it's kind of messy. It cannot equal positive negative 1, and cannot equal negative 4. So that's the final answer. All right, I hope this was helpful.